We usually picture a moon mission as triumph. Flags planted, boot prints pressed into gray dust, humans waving at cameras, with Earth hanging blue and perfect in the distance. We picture calm. We picture control. We picture NASA at its most confident. But on April 6th, 2026, when Commander Reed Wiseman and his crew of 4 brought the Orion spacecraft to within 4,070 miles of the lunar surface, they found something very different from the peaceful gray desert we'd been imagining for 50 years. What they found was a shooting gallery, active, hostile, and utterly indifferent to the 4 human beings inside an aluminum and composite shell, traveling at thousands of miles per hour, with nowhere to go and no one close enough to help. This is the story of Artemis II, and it's more complicated than you've been told. We always assume the moon is silent, dormant, a dead world that simply hangs in the sky, patient and predictable, waiting for us to visit again. It's been more than 50 years since Apollo 17's Gene Cernan lifted his boot off the surface in December 1972. And in that time, our cultural memory of the moon has softened into nostalgia. A familiar face, a quiet neighbor. But the quiet world we expected was actually quite terrifying. On April 1st, 2026, at 6:35 p.m., EDT, the Space Launch System rocket, ignited its engines at Kennedy Space Center and pushed 4 human beings away from Earth with a force that pressed them into their seats at 3 times the weight of gravity. Commander Reed Wiseman, pilot Victor Glover, mission specialist Christina Koch, and Canadian Space Agency astronaut Jeremy Hansen, the first Canadian ever to leave Earth orbit. Together, they would travel 695,081 miles over approximately 10 days. They would reach a maximum distance of 252,760 miles from Earth. That number matters. It surpassed the record set by the crippled Apollo 13 crew in April 1970 by 4,105 miles. That made these 4 people the most isolated human beings in recorded history. No one else in all of human civilization had ever been farther from home, and they were heading directly toward a world that was anything but quiet. The first thing that disorients you in deep space isn't the darkness. It isn't the silence, though both of those come for you eventually. The first thing is the scale. The human brain did not evolve to process 252,000 miles. It has no reference. It has no frame. Victor Glover, looking out from the Orion capsule, later described the experience of watching Earth shrink as something his mind kept rejecting, kept trying to reinterpret as something familiar, something manageable. Earth ceased to be a place you were from. It became a dim blue point of light, fragile and impossibly small, and around it, nothing, black. Absolute. A void that doesn't press in on you, but pulls, as though the universe is waiting for you to make a mistake. Orion is not a large spacecraft. Built by Lockheed Martin, the crew module measures about 16.5 feet in diameter, roughly the size of a large SUV. Designed to keep 4 people alive in the most hostile environment human beings have ever voluntarily entered. The walls are not armored in any meaningful sense against what lives in interplanetary space. And what lives in interplanetary space was the first real lesson Artemis II had to teach. The meteoroid environment around the moon is something NASA's Meteoroid Environment Office has been studying and quietly worried about for years, far more active than the public usually assumes. Here is the physics, stripped to what matters. At lunar distance, tiny fragments of rock and ice, some no larger than a grain of sand, some the size of a marble, travel at speeds between 30,000 and 160,000 miles per hour. Those aren't bullets. Bullets are slow by comparison. A marble-sized meteoroid, at that velocity, carries enough kinetic energy to punch through Orion's outer hull in a fraction of a millisecond. The impact doesn't leave a hole. It leaves a catastrophic breach. Pressure gone in seconds. 4 lives ended. This isn't speculation. It's physics. Kinetic energy scales with the square of velocity, which means even tiny objects, moving fast enough, become weapons of extraordinary destructive power. When that pebble hits a surface at 70,000 miles per hour, the kinetic energy converts to thermal energy almost instantaneously. The rock becomes plasma, a tiny momentary star. A flash of light, then nothing, except whatever damage it's done on the way through. As Orion rounded toward its April 6th lunar approach, the crew could see evidence of this bombardment everywhere. The surface below them, 4,070 miles beneath the spacecraft, and understand. 4,070 miles sounds like a safe distance, until you realize that's the closest any crewed spacecraft had come to the lunar surface since Apollo was visibly cratered at every scale. Not the romantic geological time craters we sketch in school science books. Fresh craters. Geologically fresh, meaning a few million years old at most, which in planetary science terms is essentially yesterday. The surface was still being hit, is still being hit, every day, every hour. What the Artemis II crew was seeing, in real time, was an active bombardment process, 50 years of assuming the moon was dormant, behind them. The cameras aboard Orion recorded the terrain scrolling beneath them, and what those images confirmed was that the meteor environment around Earth-Moon space is not the benign background noise we'd assumed. It's a constant pressure, a continuous lottery where the prize is a hull breach. But the physics of meteoroid impacts wasn't the only surprise waiting for them. Even more concerning, in some ways, was what the radiation environment around the moon was doing to their bodies in real time. Artemis II was equipped with a hybrid electronic radiation assessor, HERA, along with COS sensors designed to measure exactly what the crew was absorbing during the transit. And what those instruments confirmed was that deep space radiation is not a theoretical future problem. It was happening to them continuously, over 10 days. Beyond Earth's magnetosphere, the protective bubble that deflects the sun's charged particle emissions and galactic cosmic rays, the human body is exposed to radiation levels roughly 700 times higher than what we experience at the surface of the Earth. The crew was not receiving a fatal dose over 10 days. But extrapolate that to a 6-month Mars transit, and the numbers become a survival calculation, not a background statistic. Commander Wiseman described looking at the dosimetry readouts and feeling what he called a new kind of awareness, not fear exactly, but a recognition that the mission was simultaneously a scientific survey and a very serious biological experiment, with his own body as the data. That recognition that this was as much survival exercise as exploration was something the crew returned to repeatedly. Then there is the question of what the human sensory system does when you take it somewhere it was never designed to go. Actually, one of the most disorienting parts of the Artemis II flyby, according to crew accounts, was the visual environment near the lunar surface. We usually picture the moon as a well-lit gray landscape, easy to read, easy to navigate. In reality, the extreme contrast between sunlit surface and shadow at lunar distance is unlike anything the human visual system has a framework for. There is no atmosphere to scatter light, no gradual gradation from bright to dark. The shadows at the moon are not dark areas. They are absences, holes in the universe. The human eye keeps trying to resolve detail inside them, keeps expecting reflected light that simply isn't there. This matters more than it sounds. How do you navigate when your primary visual landmarks disappear into voids your brain refuses to classify correctly? How do you estimate distance and depth on a surface with no atmospheric haze to give you perspective cues? Christina Koch described the Terminator line, the boundary between lunar day and lunar night, as looking like the edge of reality, not the edge of the moon, the edge of everything. Depth perception, which we rely on constantly without noticing it, requires 2 eyes and a brain calculating the tiny differences between their inputs. It requires atmospheric distance cues. It requires scale references against familiar objects. The lunar surface provides none of these in the expected ways. The crew's trained adaptation to this perceptual environment was itself a data point evidence that human beings will need significant recalibration to operate safely on the surface. There is one more anomaly that deserves mention, one that scientists at institutions, including the University of Bologna, have been studying without full resolution. The flyby anomaly, an unexplained, slight discrepancy in spacecraft velocity during lunar and planetary flybys, has appeared in mission telemetry repeatedly, tiny. About 0.7 millimeters per second in some historical cases, small enough to be noise, persistent enough not to be. It turns out we do not have a complete accounting of every force acting on a spacecraft at lunar distance. Our gravitational models are excellent. They are not perfect. And in an environment where margins matter, where the difference between a successful trajectory and a missed return window can be measured in fractions of velocity, imperfect is a word that commands serious attention. Artemis II flew. It returned. On April 10, 2026, the Orion capsule splashed down off the coast of San Diego. 4 human beings, alive and intact, after 10 days and 695,081 miles. A record-breaking journey into a frontier that we had, collectively, allowed ourselves to think we understood. We didn't. We don't. Not fully. Not yet. But that is exactly the point of Artemis II. Not to answer every question, to discover which questions we hadn't thought to ask. The moon is not the quiet, familiar neighbor we remember from 50 years of textbooks and cultural mythology. It is a kinetic, radioactive, perceptually hostile environment sitting 252,760 miles from the only world we've ever truly known how to survive on. And if we are going back permanently, and we are then learning to survive, that environment isn't optional. It is the entire project of human spaceflight from here forward. The crew of Artemis II did not just fly around the moon. They gathered the intelligence we need to stay alive when we land on it. And what they found should change every assumption you had walking into this video. The moon is not waiting for us. It's testing us.